We're now going to walk through the implementation of case study ex14. This case study shows how the Java consumer and function functional interfaces can be used to print and sort thread objects by their name. As usual, you can find this case study source code in the ex14 project in the FP folder in my Modern Java GitHub repository. So here we are in that project. Let's take a look at the ex14 file, which shows how a modern Java consumer interface can be used with the for each method to print out the values in a list by binding the systemoutprintln method to the consumer parameter on the for each method. And it also shows how to sort a list in either ascending or descending order by using a comparator and a function functional interface. So let's start by taking a look at a nested class called myThread that extends the thread class. This particular class takes the name that's passed to it and passes it up to the thread constructor, so that becomes the name of the thread. And then we also override the run hook method in order to print out the thread ID and the name of the thread. And we'll use this for debugging purposes once we start showing the actual code. Here's the main entry point into the test program. As you can see here, it creates a list of myThread objects that takes myThread for Larry, myThread for Curly, and myThread for Mo, and then turns them into a list by using the arrays as list factory method. We then go ahead and print out the contents of the original list by calling the for each method defined on the threads list and passing in the system.out.println method reference. So that'll go ahead and print out the content. We then call the sort method that's defined on the threads list, and we pass it the result of applying the comparing method, passing in the thread : getName function. And that, of course, will end up sorting the thread objects by their name in the default order, which is ascending order. So you'll end up getting Curly, Larry, and Mo, which we then go ahead and print out by using the for each method and the system.out::println method reference, as we did before. Now, just for fun, we're going to go ahead and sort the thread objects by their name in descending order. You can see how we do that. We use comparator comparing. We pass in the thread : getName function, and then we apply the reversed method that is applied to the result of what comparing returns. And so we end up calling sort, and it'll sort by name in descending order. So that, of course, would be Mo, Larry, and Curly. And we get that result when we print things out using for each and system.out::println again. And then the final thing we're going to do here is we're going to go ahead and start all the thread objects. And we do that by using, once again, the for each method that's defined on the threads list. And we're going to pass in the thread : start method as a method reference. And that will call start on each of the objects in the threads list, which will go ahead and start the threads. And when their constructors get called, as we'll see, they'll print out information about each thread, the thread ID and the thread name, for example. And then the final thing we do here is we once again use the for each method defined on the threads list, except this time we're going to go ahead and wait for all the threads to finish running, which won't take very long, of course. But this is a nice example of a barrier synchronizer. Thread : join is a barrier synchronizer that waits for each thread to finish. And we're going to wrap this up with a little adapter method called reThrowConsumer, which comes out of the exception utils class. And reThrowConsumer essentially binds or adapts a consumer that has an exception. In this case, that's going to be the join method, which can throw the interrupted exception. And it's going to go ahead and convert it or adapt it to not require the client to explicitly catch that exception. Instead, we push it into this little wrapper here, or this decorator, and it turns around and calls except. If an exception occurs, that checked exception is caught and then rethrown as an unchecked exception by using throw as unchecked, which is just this little helper method here that wraps up the exception and throws it as a runtime exception or an unchecked exception. So this cleans up the code. Otherwise, we'd have to put a try-catch block here, which is kind of ugly. So that's basically how the program is implemented. Let's take a look at what happens when we run it. As you can see here, it goes ahead and compiles, and then it'll run. And the first thing it's going to do when it starts to run is it's going to print out the original list of the threads, which, as you can see, have Larry, Curly, and Mo in the order they were created into the list. We also print out the thread IDs as well. Then we sort things in ascending order, so it becomes Curly, Larry, and Mo. Then we sort the list in descending order, so it becomes Mo, Larry, Curly. And then finally, we start the thread objects. And as you can see, the constructor here prints out the thread ID and the name of the thread. So that's a nice, simple example that demonstrates how we can apply consumer and function together in a simple case study and demonstrate how we can use them to name threads and then do various operations to print and sort the threads.